Alright, so today it's day 67. I already did, today what I did was mostly I studied a bit of networking, and I did technically these two problems. But this one I have to check it again, so I will not count it. And I did this one, permutation in a string. We are currently at 33 out of 150. And yeah, that's it. Let's do it again. And for this one, I'm gonna read the problem, permutation in string. We are given two strings, S1 and S2, like this. And we're gonna return true if S2 contains a permutation of S1. So in this case, ABC, a permutation, it's CAB and it's contained in S2. And false otherwise, that means if the permutation S1 exists as a substring of S2, then return true. Alright, so here, what was the solution? I realized that LeetCode is a lot of just pattern recognition and even implementation from memory. So I'm starting to not like it that much, because it's too much about memorizing. Yeah, but it's okay. I'm gonna finish. It's only 150 problems and I'm doing like just 1-2 a day, so it's okay. But maybe I should switch to competitive programming. That seems more interesting. But alright, let's do this one. So essentially in this one, if we have like these three numbers, we can start by, we can construct like two sets of lists of size 26, which one, like every index is it's gonna be like a letter in the alphabet, and whenever you encounter that letter, you're gonna have like a vector that represents like this string. So this string is gonna be 1 if it has the string, 0 otherwise. So it means that if you have ABC and CAB, if you count how many A's, how many B's, and how many C's, the permutation is going to be the same. So like the most important condition, which is going to be like an equality condition, it's just going to be like both frequencies of the both constructed strings are the same. That's going to be the intuition, because permutation is like frequency invariant, we can say. And that's it. We check these three strings. If it's not here, we move it by 1. Not here, we move it by 1, and so on. That's it. So let's start by, we can do like a little optimization at the beginning. Let's do it quickly. So first we define, we just get the length of both these strings, and we are searching if this first string is in the second one, if S2 contains a permutation of S1. So it implies that if S1 is bigger than S2, then there is like no permutation, right? Because you cannot contain that many elements if it's smaller. So we can say if M is bigger than N, then return false. So we can like skip some edge case very quickly. Then we can build like both of the lists. I'm gonna call it maybe list 1. And this is gonna be, this is the initialization, and then we can iterate, also list 2. Now we can iterate over M. So we're gonna say for what can I say, for I in range M, no, for I in range N, because this is N. So for every element here, what I want is, no, it has to be in range M, because I want it in the smaller one. So essentially I want to check like the first character and add it like to the list as a frequency. So I'm gonna say list 1 the index, so I gotta make the index. So I'm gonna say like the index of the first list, it's gonna be we have to convert the character, which the character is gonna be s1 of I, and we gotta make it start by 0. So we get, we put just ord of A, yes, because we only have lowercase letters, yes. So we add 1 to this, good. Then we do the same for the list 2. But I'm gonna say this is index 2, this is s2, and index 2, and list 2. That's it. And then we can check if list 1 is equal to list 2, then return true. So basically what I'm saying is if literally s1 it's contained in the first 3 elements of s2, which not always is going to be the case, but it's like a tiny optimization. Then we can do the actual sliding window. So I'm gonna say for I in range, so we gotta start, we do it by m without reaching n. So now we start by m and we do it until n, and n is the length of the bigger string. So we do this, and essentially we're gonna do the same. Right? The only thing that we have to take into account is that we are moving like the window, and the window is technically s1, right? So here is the window, and every time that we move the window we have to add like the character, the current character, and remove the previous one. That's it. So to adding the current character, this is gonna be the same, but then to remove the previous one, if I have to remove this value and I'm at this value, because if I do the first iteration I'm gonna have these two numbers, then I'm gonna start this one at A, and then I'm gonna add 8 to the frequency, so it means that I'm gonna have a vector which 4 ones, the first 4 are ones, but then I'm gonna remove the L, and the L is because I started at m, it's gonna be I minus m. Yes, but I don't want the index, I want the character at I minus m. So I'm gonna do a string to, I minus m to get L, then I map this character L like to the vector and find like the index of that character and remove one. So I can say essentially I minus m and minus equal 1. Then I can check at every iteration if this is true. And if we finished and we didn't find this, we're going to return false. And we got index out of range. Let's see why. Okay. So if we are doing the for loop for I in range from n to n, and I don't know why did I put this one here, because we are iterating over, we are moving over S2, not S1. So this should fix the okay, but now we have an error. I gotta check. The code looks fine. And I could have missed something. Yeah, it looks fine. Let's see. So AB, the output is false and it should be true. So I'm gonna have 1 1. Yeah, it should be true. That I minus or A is the index. We are not using list 1, we are using list 2. Like list 1 is completely fixed. So I don't know why did I put list. We are just updating list 2. Alright, so it should be. That's it for today. And how many? I am at 33 out of 150. Yeah, probably I will finish like in a month or something. Or probably like even 2 months. I will see. But that was it for today.